Hello, my name is Joan Romero Clausell and I'm going to present the results of the life cycle analysis of interlocking panels and the annex of the comparative scenarios. I am working in the Valencia Institute of Building, and this is going to be the part of the delivery of the IMIP project. As an introduction, this is the panels. The delivery summarize all the results and the different indicators of a life cycle assessment. And during this assessment, we have been choosing 4 kinds of panels that we're going to see later on. And these panels are composed by wood and cork. This assessment has been elaborated through the IMIP software. To sum up, a life cycle assessment have these kind of stages or phases, and the product stage, the construction stage, the use stage, the end of life stage, and beyond the building life cycle stage that summarize or indicates the capability or the potential of a product, system or service to be reused, recovered or recycled. As we're going to see later, each kind of stage have different inputs and outputs, and normally the most important and the most shown stage on the life cycle assessments are the production stage, where the embodied impact is shown. These are some of the indicators that normally life cycle assessment can be assessed or can assess. There are, for example, environmental assessments, resources assessments and indicators, or residues indicators. All the working throughout the life cycle assessment is structured with inputs and output flows, with materials or with energy. Another step we are going to see later is the life cycle inventory assessment that is worked through an engine of impact categories, scheduling all the indicators and all the impacts in different kinds of categories depending on the focus of the assessment. All these ingredients, all these flows are assessed through a method that is recorded and is implemented in the database of the engine, in our case IMIP, and the output of this assessment are these impact indicators, like for example the ones that you can see in the chart on the right side. Like for example, the most popular and the most common that is the representative of the carbon footprint, that is the global warming potential of kilograms of equivalent CO2. Why is interesting this kind of assessments for the timber products and constructive systems? It's because the wood is capable to store and sequestered CO2. And for example, at the bottom of the slide, you can see that almost or more or less the 50% of the material, the weight of the wood, is CO2 that is stored in the material. So in order to reduce the carbon footprint of the buildings, to use wood is key in order to reduce the emissions and the embodied carbon of the constructions. Also, on the other hand, the biogenic footprint is interesting because compared to different kind of products, for example, the concrete or steel that is emitting fossil carbon footprint, the biogenic carbon is a cycled emitted and absorbed biogenic carbon that is balancing throughout all the life cycle of this kind of materials that at the end have a different balance compared to the common and the conventional products of the conventional construction markets. For instance, you have here a comparative chart from different products, homolog products, for example, PVC, steel, recycled steel, aluminum, brick, and so on, compared to sawn timber. Not even is lower, the sawn timber, but also is negative compared to their competitors. So obviously this is a really good advantage when, for example, in tendering, the carbon footprint is a key value to access to this kind of procures. Or, for example, a whole house compared, comparing, for example, a timber house, a wooden structure house, compared to concrete and steel house. You can see here that the CO2 per kilogram and per square meter have a really good and a really important difference to take into account. There are some available databases that have these indicators already as an input that you can consult. For example, the IVE, the Valencian Institute of Building, have these indicators where you can download and preview these indicators in order to compare, in order to build up a project with all this kind of information whenever the procedure asks to write down all this kind of information. What are the IMIP panels and how are they composed? The first part of the life cycle assessment is to properly define, and for example, the ancillary materials of these IMIP products are basically sawn wood or wood, mostly from pine. The adhesive that are polyurethane adhesives, OSB panels, oriented strand boards, and the cork panels, and sometimes are loose cork and sometimes are cork panels, depending of the kind of product that you are building up. You can see the rest of the deliverables to see the proper components and how are assembled these products. For the life cycle assessment, we have chosen these 4 types that are basically the roof, the slab floor, the sandwich one, and the facade one. So since this, the percentage of the ancillary materials are different, it's important to have at least separate results in order to later compare to the homolog conventional systems. The results of the life cycle assessment are structured in different phases. The first of all is the process identification, and for example, the software that we are using, the SIMA Pro, have a database, a library of different processes that we have to adapt, we have to modify it and to edit to see how, for example, are similar our products to the IMIP projects, and little by little editing it to the characteristics and the features of the IMIP projects. For example, changing the pool, the energy pool, the electricity pool, changing, for example, the distances from the manufacturers to the construction site, and so on. Later, we have to choose the assessment method that is more suitable for the indicators and the results that we are asked to. For instance, we have chosen, for example, the global warming potential, 100 years, and this one is the most used, for example, for the carbon footprint. So we are choosing the different ones that, for instance, we have prepared, and for more details, you can go to the deliverable to see which ones are suitable for each indicator that we are going to calculate. At the end, depending of the percentage of view that you want to show in the diagram, we have the flows to see and to hotspot which ones we are going to reduce, or which one we have to focus on in order to, for example, for the industry, for the manufacturers, in order to reduce, for example, the carbon footprint, to optimize or to improve the processes. You have here, for example, the comparative charts. If you want to show in a report how is shown and how are all these indicators in order to reduce them. And here you have the charts. For example, you have the global warming potential total, the fossil or the biogenic. You can see here, for example, that in the manufacturing stage, we have negative numbers because of the sequestered CO2. And also interesting to highlight at the D stage, we have also negative numbers because we are recycling and disassembling and recovering the materials and the construction system at the end of the life of the products. So again, these numbers are negative, and at the end have really good results compared to different conventional systems. For example, we can see here, compared, for example, the IMIP D, that is the facade, to these conventional layers and configurations, we have negative stages with negative results compared to the common brick wall facade that obviously in some strategies and in some projects has really good advantages. The comparison could be also from, for example, the concrete floor, or compared, for example, with the roof to another IMIP products, that if you want more information or deeper detail, you can go straight away to the deliverable of the IMIP projects. Thank you very much.